today we're going to actually use those formulas you came up with yesterday, so hopefully you got them right. 9 for day 2. So, using the formulas to fully integrate. So it's just repeated use of those reduction formulas until you're down to something you can integrate. 2 examples today. We're looking at integrating cosine to the 5th x dx fully. So, with that formula handy from yesterday, let's see if I can get it on here. Okay, cosine to the nth. So if you missed this case, n is a 5. The reduction formula says take 1 over n, so that's 1 over 5. Cosine to the n minus 1, that's going to give me 4, times sine, plus integral n minus 1 over n, that'll be 4/5, times cosine to the n minus 2, that'll bring me down to cubed, x dx. Okay, cosine cubed is not something I can integrate, so I'm going to apply the reduction formula to this problem, to this portion of the problem. So, I still have this, 1/5. I'm only going to carry this once and I'm going to ditto, but I just wanted to slide it over so I had enough room. Cosine to the 4th x sine x plus. Now this 4/5, and this is probably the trickiest part, is knowing what to carry along here. It's 4/5 times this next reduction formula. So I'm going to pull the 4/5 out, and I know the reduction formula has 2 parts to it, the leading part and then the integral again. So I'm going to use brackets. So now applying the reduction formula with n now being a 3. So I'll start it over. 1 over n, so that's 1 over 3. Cosine to the 3 minus 1 gives me cosine squared, times sine, plus the integral, n minus 1, that will be 3 minus 1 is 2, thirds, cosine to the n minus 2, that's 3 minus 2, that's cosine to the 1st, x dx. Now this is something I can integrate, so I'm ready to finish it up. So 1/5 cosine to the 4th x sine x plus distributing the 4/5 in, that will give me 4/15 cosine squared x sine x plus distributing, that will give me 8/15. Antiderivative of cosine is sine plus c. So hopefully you won't have to apply it too many times in a problem, otherwise you're going to be running out of room. But let's try one more to get the hang of it. Let's try a tangent to the 7th x dx. Let's see, tangent was right here in the middle. Okay, got my reduction formula handy. And the n is a 7 in this case, so here's my formula. I'm going to start it down here so I can ditto this time. 1 over 7 minus 1, so 1 over 6. Tangent. 7 minus 1 is 6. Minus the integral tan to the 7 minus 2 is 5. So I'm going to apply the reduction formula here with a negative out in front, so I'm going to distribute a negative. I'm just going to ditto that beginning, a negative, and then brackets, reduction formula here. N is now a 5. So 1 over 5 minus 1 is 1/4. Tan to the 4th x minus the integral of tan, that'll be to the 3rd x dx. I'm going to stop and take a look and make sure I haven't made a mistake yet. Sine 6, 1/4 minus, okay. So distributing the negative here, and then applying the reduction formula here. One more time, hopefully. So ditto this. This will be minus 1/4 tan to the 4th x. Now plus a reduction formula. Not that I need the brackets, but I just want to get in the habit of it just in case there's something out here. But it's a positive one, so it's not really necessary. Write up reduction formula with n being a 3. So 1 over 3 minus 1 is 1/2. Tan to the 2nd minus the integral of tan. 3 minus 2 is 1, x dx. So, looks like we're ready because the integral of tangent I have on that blue sheet. And so do you. Tan's antiderivative is, there was an option here. You can use either one. Doesn't matter. And then we'll be done. So 1/6 tan to the 6th x